The second example we have is something that's not linear. And we're talking about an object being dropped. Now you know the acceleration due to gravity picks up every second that an object is falling. So the way we represent something that's falling or something that's being thrown is with a parabola. You saw that before back in chapters 2 as well as back in our parametric section. So when you see something being dropped or something projectile, you've got to be thinking parabola. And when you think parabola, you think of a quadratic. So this next example, we want to determine what model best fits the data and use the model to predict when the object will hit the ground. You can see here I give you up to 1.6 seconds, and if we're starting at a height of 32.1, after 1.6 seconds I can see at 17.12. How many seconds will it take in order for the object to hit the ground? So once again, my list 1 is going to be X, my list 2 is going to be the Y's, and I want to find the best fit model for the calculator to determine the graph. So let's start by going to Stat, Edit. And I've put in all my values ahead of time, 0 all the way down through 1.6. And as you plug in these values, especially with the second list, double check to make sure that you have the same number of values in list 1 as list 2. If you don't, you will get a dimension mismatch, which then will cause an error down the road. Can't do any calculations. So let's make sure these lists have equal number of values and just do a quick double check to make sure that your numbers are accurate. Just mistyping one of them can throw off your answer. Now, since we know that this is a quadratic because of the fact that this is accelerating due to gravity, we've got to use quadratic regression instead of linear regression. The other thing I want to do is I want to know when the object is going to hit the ground. So I've got to store this graph in Y1 so I can look at my table to determine what is it going to be in the future. Up here I didn't ask for what is the future value in 2010, so I didn't need to store this in Y1. But down here we are going to need to store this in Y1. So we're going to start by going to Stat, Calc, and we are going to go to quadratic regression. And we've got the X list, the Y list, the frequency list, store regression, and then calculate. Here where I can store the equation, the quadratic regression equation, we're going to do that under our Y variables. So if I go to variables, which is the variable button right next to program, I go over to Y variables, and since I'm in functional mode, I'm going to choose function and then choose Y1. Now I can see store regression equation in Y1, and then I'll choose calculate. And I can see here with the quadratic, I get ax squared plus bx plus c. So my a value is negative 2.75, which indicates my parabola is going down. My b value is negative 5.27, and my c value is 32.32. My window I want to set for this, you can see here the time goes from 0 to 1.6, so we'll go something slightly larger than 1.6, which I chose 2. The height goes from 32 down to 17, so I went something a little bit larger, 35, and went down to something a little bit less than 17, which is 15. So that's a difference of 20, so an x scale of 2. And when I hit graph, I can see that curve for the parabola goes through most of those values. So I'm going to now want to predict when is the object going to hit the ground. I can see right there, since I stored in Y1, everything is there for me, the whole big long equation. So to determine when it's going to hit the ground, I'm going to go to my table. And I'm just going to scroll down until I see my Y values go to negative values. So right there, I see 2.6 and 2.7 is when I go from positive to negative. So use this model to predict when the object will hit the ground. It's going to be between 2.6 and 2.7 seconds. And this graph looks like a parabola, so I'm going to have to use the quadratic regression.